Let's continue going through three variable simultaneous equations here, and this time we're going to see equations that result in infinite solutions. So last time we saw equations that resulted in one solution or no solution, one pair, XYZ pair, or no solution. So let's take a look at why this is infinite solutions. Look at the first two equations here. If we add them, the z's will cancel out, plus z and minus z. And so we'll have x plus x is 2x, y plus y is 2y, and 2 plus 2 is 4. So now, here's what's interesting. Even though we know there's going to be infinite solutions, we can still solve for one of the variables, and that would be z. Look at these two equations here. 2x plus 2y plus z, 2x plus 2y. Both of these are equal to 4. This one has a plus z, this one doesn't. So since the plus z doesn't change the solution, we know that z is equal to 0. So what that means, if z is 0, then we can take z out of all three of these equations and still get the same result. So x plus y, it will be 2. X plus y will be 2. And 2x plus 2y will be 4. We took out the z's in each one of these. Now what you can see here is that all three of these are the same equation. Obviously the first two are the exact same, but this last one is just the same thing multiplied by 2. So what we were actually given, because z equals 0, is three identical equations, and because of that there's no way to solve this. It also means that we have an infinite number of solutions. But we can sort of half solve this. We already know what z is equal to, but let's take a look at this first equation here. We can find not what number x is equal to, but we can find what it's equal to in relation to y. So if we move y to the other side, we can get x equals negative y plus 2. Now, of course, we can do the same thing for y. We can see what y is equal to in relation to x. And we will get y equals negative x plus 2 if we move the x over. So now, from these equations here, we can actually write an ordered pair. So let's take a look at the first one. We know that x is the same thing as negative y plus 2. So instead of just writing negative y plus 2 for x, instead of writing x for, we will write negative y plus 2 for x. And this is based off of a given y, so we're just going to leave y as that. And z we know is equal to 0. So we haven't found what each number is equal to because there are an infinite number of possibilities. But we do have, this is based off of a given y. Based off of a given x, if we have a given x, we can use this first equation, the second equation, to say that y is negative x plus 2. So instead of just writing y, we'll write negative x plus 2, and we know that z is equal to 0. So either of these two pairs of solutions here is correct. X is always going to be negative y plus 2, and y is always going to be negative x plus 2. And z will always be 0. So because of this, we can come up with some possible solutions that would work. So let's look at the first one here. Let's say, so we have x comma y comma z. Let's say we start with a y of 5. what would x be? X would be negative 5 plus 2, which is negative 3, and z is always 0. Now, if we start with x, in this one, say x is 3, we can find another possible solution. Y will be negative 3 plus 2, which is negative 1, and z will be 0. So here we have two possible solutions. Again, there are an infinite number because we could start with any number for y or any number for x. But these are the ordered pairs. One of these is what you want to come up with if you have a simultaneous equation with infinite solutions. Okay, let's take a look at one more. So here you can see that we once again have the same coefficient in front of all of a variable, the y here. That often indicates an infinite solution. But once again, there is one variable we can solve for. If we subtract this second one from the first one, 2x minus 2x is 0, 2z minus 2z is 0, and we'll be left with y minus negative y, that's 2y, equals 7 minus 1, which is 6. So y will be 3. So now that we know that, we can substitute 3 into all of these equations here. So we'll get 2x plus 3 plus 2z equals 7. 2x minus 3 plus 2z equals 1. And 5x plus 3 plus 5z equals 13. Now let's simplify all of these by bringing the 3 to the other side. So this one will become 2x plus 2z equals 7 minus 3 is 4. This one is 2x plus 2z equals 1 plus 3, which is 4. And this one is 5x plus 5z equals 13 minus 3, which is 10. So once again, as with over here, we have three equations that are identical. These two are exactly the same, and this one is the same thing, just multiplied so that we have coefficients of 5. So there are once again infinite solutions. But we know that y is equal to 3. So we can solve for x and z, not to find what numbers they're equal to. But let's use this first equation here, 2x plus 2z equals 4. We'll first divide everything by 2 to make it simpler. X plus z equals 2. And now from here we can easily see that x will be equal to negative z plus 2. Or if we move the x over, we could say z equals negative x plus 2. So the solution pairs that we could write are, instead of writing x, we'll write negative z plus 2, y is 3, and this is based off of a given z. For this one, if we know z equals negative x plus 2, then that is for a given x, y is 3, and given x, z is negative x plus 2. So, just so we're clear, the way this works is you have one letter that is just the letter, and then you have something else that is based off of that variable, and then you have one variable that you know the exact number. That is how these solution pairs for infinite solutions work. And again, we can come up with some possible solutions. So if we look at the first one here, given a z of, say, 6, x would be negative 6 plus 2, which is negative 4, y would be 3. Given in this one, if we start with an x of I don't know, let's just say 0. Y is always 3, and negative x plus 2 is negative 0 plus 2, which will be 2. So those are some possible solutions. But really what you want to focus on is coming up with one of these pairs where you can solve for one variable exactly, and then you pick another variable, and the third one is based off of that one. And again, what creates infinite solutions is the fact that, as you can see, we already came up with 2 here. We can come up with an infinite number that satisfy both of these pairs of solutions.